You're watching InTechnology, a video cast where you can get smarter about cybersecurity, sustainability, and technology.
Hi, I'm Camille Morhart, host of InTechnology podcast. And today I'm going to have a conversation with a VP of Emerging Technologies at Ericsson. His name is Mischa Dohler. Very interesting person. We are going to talk about the intersection of emerging technologies with telecommunication systems globally, as well as their security moving forward. Mischa has a very interesting past. He was actually born in East Germany, and he is half British, half German. He lives in the United States now, and he used to be for a decade a professor and chair of the wireless communications department at the King's College in London. He's a IEEE fellow, a fellow of the Royal Academy of Engineering, also a fellow of the Royal Society of the Arts, an advisor to the FCC, an author, a pianist, and probably a bunch of other things I'm forgetting, but very passionate human being, really looking forward to discussing a bunch of different topics across technology. Welcome, Mischa.
That's absolutely correct. And I did a lot of other very exciting things we can talk about with the arts and with health and music.
Oh, well, let's start with that. What very exciting thing did you do with the arts?
All right. Look, I worked. I always maintain that we shouldn't be doing technology for the sake of technology. It really should be for people, for society. In the end of the day, so I spend a good deal of my time in the UK with people trying to understand how would they use future technology. So in the early days of 5G, I would go to surgeons, I would go to artists, I would go to musicians, and I would ask them, hey, if we threw out a technology called 5G by 2020, how would you use it? And I learned so many things. So I worked with Rob Del Naja from Massive Attack. Some of you may know him. I worked with the National Theatre, with the National Gallery. And really my highlight was actually to work with our surgeons at King's College in London on this concept of 5G telesurgery. So you would essentially have the surgeon, the patient separate with a 5G link and save lives simply because you can operate much quicker. And my highlight now is, my highlight of this week was I just returned from Florida. So for the listeners who come in later, this is February. We're talking February 2024. And I was with 200 surgeons in Orlando. There were 10 sitting presidents of medical societies, representatives from the White House, FDA. We had loads of folks there, robotics surgery companies, myself, and we demonstrated, and that was pioneering. We demonstrated the world's first 5G live operation over 10,000 kilometers. So we were from Florida, Orlando, to Dubai and to Shanghai. We did 2 operations. And it was really a stunning milestone moment for the community. And we really believe we can make a difference there using technology we are developing as an ecosystem.
What were the operations?
So we did this specific operation started, don't laugh, with a chicken wing, okay, presumably out of the supermarket. The next one was on a banana, so you could actually test the soft tissue issues. And the third was actually on a pig, so they did an operation there. But we did already previously we did actually operations over shorter distances on humans because the regulator allowed for that. So it's a really exciting development, and we have now a path forward on how to use that in the US and globally to save lives.
Oh, that's interesting. I was going to ask you how far along we are, but it's good we're operating on fruit, so I have a sense of it, and I prefer that as a first start.
Yeah, some people like their fruits of different shapes, so maybe we need to call it. No, just kidding. But we do have, there are some cases, of course, which really require an urgent intervention. It's called actually an emergent, so really highly urgent intervention. If there's no intervention, the patient would die. So therefore, we're really looking at cases related to stroke, to heart failure. So these are the type of use cases we are after at the moment.
I assume it's a certain kind of robot or machine that's performing the surgery?
Yes, and that's a universe on its own, and it was pioneered here in the U.S. Maybe 40 years ago by Rick Salvato. He came up with the idea: let's use robots to do the intervention because they're so much more precise. Patients recover much quicker. Then 30 years ago, Fred Moll founded a company called Intuitive Surgical, which actually built a commercial product around this. Then Jacques Marisco, 20 years ago, did the very first teleoperation from France to New York. Then 10 years ago, I pioneered that 5G telesurgery concept. And today we have companies building the actual products which are able to operate over long distances. So the answer is yes. And it's a growing and thriving ecosystem.
Interesting. So let's move to the arts. What is 5G going to do in the arts?
That's a great question. I'm actually a musician. I'm not sure you know this. So I want to become a professional pianist and composer. And so I really was trying to understand how can we bring this emotional bond between artists and the audience. How can we enact it remotely the same way as if you go to a concert. So if you go to a live concert, you listen to somebody, Beyonce, these emotions are very strong. And I was trying to understand what triggers that. It turns out that latency is very important. So when we communicate over the internet, the time it takes for signals to reach each other, is often hundreds of milliseconds, simply how the video codecs work, security works and all that. Whereas if you and I are in the same room, I have about a 20 or 10 millisecond latency. So my emotional response in the brain is very different. So we started to use 5G technology as an ultra low latency technology to kind of shorten that distance and therefore recreate that emotional bond. So we did the world's first 5G concert, and that was me playing the piano in Berlin under the Brandenburger Tor, and my then 8-year-old daughter, Noah, singing in London, and we were able to connect each other at 20 milliseconds. So we didn't get it down to 10, but 20 milliseconds is remarkable. 20 milliseconds, she was with me, and I really struggled not to cry during that performance because the emotional bond was so strong. I have my daughter 1,000 kilometers from me, beamed in, and we're giving this joint concert. So these are the type of questions we're trying to answer back then.
And what about holograms for concerts? Wasn't ABBA working on that?
Yeah, probably. I'm not sure there will be maybe for artists to be on stage. There are companies who really work on holographic projections. There was a lot of work done in London when I was there with Madonna, with Mamma Mia, so ABBA. So there's a lot of stuff actually being tested. I think now with the release of augmented reality devices on virtual reality or pass-through virtual reality, like the Vision Pro, Quest 3, and later we will have, maybe the Ray-Bans and more advanced stuff, Magic Leap, you name it. There's a huge swath of glasses coming out. Suddenly you are able to project essentially these experiences right into your eyes. So you may want to have a hybrid experience. You may want to go to the concert actually, and then have an overlay. You may want to be at home. You may want to be with friends. So I really think the next 10, 20 years will completely change the way how we engage with the arts. And therefore, I also believe the way how arts will be procured will change. So just think back, how let's say the Greeks or the Romans invented the theater stage, which was an innovative step on how to do theater. And then a lot of creativity has happened over the last 2,000 years, but there was no real disruption on how we consume that art. So I think, that stage consumption, will change.
So how do you think do you think it will change television or movies that are already coming through digital interface?
So, our viewing behaviors have changed. So if you think about it, maybe 100 years ago, we went to the cinema. So the screen was 20 meters away from you. And then TV was introduced and suddenly it was at 2 meters from you. And then, we invented the smartphones and suddenly it was 20 centimeters. And now we are putting out the trajectory is very clear. As a techie, I predict the future by just looking what's the trend in the past. It's not very difficult. So therefore, we will now start consuming content, which is about 2 centimeters from the eyes through these glasses. And, the Vision Pro is just a testament that this will truly happen, and Apple has partnered with Disney to produce entirely new content. They just partnered also with Epic. Disney, I believe, and Epic have partnered to build metaverses, gamified experiences. So we'll start producing it much closer to the eye. And it's not difficult to predict what comes next because the 2 centimeters go to 2 millimeters the moment you start putting on contact lenses. So that would be the next step. And then the next step would be a Black Mirror moment, and I'm not taking any stance here whether it's good or bad, but probably neural implants to have that recreated right in the brain will probably happen towards the middle of this century.
So in our vein of running through different technology categories, if we were to pause on AI machine learning, what from a telecommunications perspective are you most interested in that space?
Yeah, Telecom was always very interested in the general families of AI. So we have, we have been using whatever computer scientists came up with, whether that's convolutional neural networks, recursive neural networks, RNNs, or the implementable version of LSTMs. We have been interested in GANs, and there are loads of applications there. We're going this roadmap of networks which were tuned very manually to networks which are now tuned by AI, simply because the degree of freedom you have in the network is so large. There's no way you can do this as an engineer. But the future now going forward becomes really interesting because we are introducing generative AI capabilities into our networks, which opens up a whole swath of new applications. And maybe the highest, the lowest hanging fruit in a sense, so an opportunity which is very close, is really to use kind of chat bots to engage, for the likes of the telco operators to engage with their customers. They can scale operations, but also for us as Ericsson, because we have a lot of gear out there which is fairly complicated to operate. So whenever our operator customer has a question, rather than calling up, let's say a human Ericsson employee, they first can consult essentially a chatbot which has been trained on Ericsson data with Ericsson employees. So that is a real opportunity there, low hanging fruit. But it goes on that we use it, for writing code. We can use it to emulate large systems rather than going out in the wild and driving around and testing things. You would use generative AI to recreate these scenarios, so it becomes much cheaper to launch new ideas. And of course, the kind of the third one, and which is the holy grail, is to use Gen AI to help you design these systems. And that's actually being used in the semiconductor and the chip industry quite a lot. So if you talk to NVIDIA or you talk to Synopsys, these companies have been using AI to generate their next generation, chip fabric for quite a while. Why can't we do that? So that's a natural question. And we are quite excited about using this generative AI capability to really design telco networks of the future. Will be co-designed with the human engineer, of course. Nobody will get rid of us as engineers, but at least our capabilities will be 10x, so really kind of empowered. Will be like the magic one for us to go forward.
So Mischa, I'd love to spend just a minute on you as human being. You're so well versed in so many different technologies. Is that a tactic that you use? Do you spend a certain amount of time each day on different technologies? Or how do you become so knowledgeable about so many different things?
I'm a very curious person. So, and I am also a person who likes to deep dive a lot. So I'm not satisfied just to understand the cheerleading high level stuff. I really try to deep dive as deeply as I can. I do upskill a lot. So you'll be surprised. My day is actually literally 1 hour dedicated. I really religiously dedicate an hour on upskilling. And because my day is so full as VP of Emerging Tech, I get up at 5 o'clock and I'm in the office 5:30. And I have my 6 a.m. to 7 a.m. I'm dedicating really to upskilling, trying to understand what's out there, using new tools. And it has really been quite helpful to me to understand, anything very basic from quantum technology, neuromorphic, blockchain. I'm just a new book actually on 6G and blockchain is coming out in April, which I've written over the last years. And I also spend a lot of time on system thinking end to end. I'm thinking a lot about policy. So I'm on the board of Ofcom, which is our UK regulator, spectrum regulator, and on the technology tech advisory committee of the FCC. So a lot of policy thinking as well. And I spend a lot of time thinking about humans as well. That very emotional relationship of people with people, people with technology. What's the role? I never forget that. I'm thinking about my children. How will my daughters grow up into that tech century? What will 2050 look like? What can I do today to make this a better future? So that's a little bit my thinking, how I tick internally.
So from a physics perspective, explain neuromorphic computing to us.
So it's an entirely new compute paradigm, right? So in the computer science world, we talk of a von Neumann architecture. So von Neumann introduced that architecture saying, hey, let's have the compute engine, which we call CPU these days, decoupled from the memory where you store your information and then connect it with a little bus there. And it takes a lot of time to actually get this information forth and back between memory and compute, costs a lot of energy. And, companies like Intel and others really build a whole business around that. Now, along comes Neuromorphic, where you have actually completely new materials which allow you to put computing and memory in the very same instance. So you don't need to ship all that information forth and back. You can do it in many ways. One way is just to use very new material, like kind of metamaterials, to make that happen. And it turns out by doing this, you save a lot of energy because you can suddenly just maintain part of the little chip infrastructure which you need to do certain calculus, rather than keeping everything powered at the level of ones and zero as we do with our traditional infrastructure. So it turns out that bringing this at memory and compute together, we save a lot of energy. Then people came along, said, hey, why don't we build entirely new ways of calculating things? And the neuromorphic compute fabric allows us to do operations without using energy for multiplications. And multiplications, we need that a lot, right? So we roughly have additions and multiplications. Now, multiplication take about a tenth of the energy today in neuromorphic. Put it all together, and suddenly very complex operations like AI consume a million times less energy than our traditional CPU fabric and GPU fabric. And everybody was, hey, why don't we use that? And everybody got very excited about this. Of course, loads of technology challenge. These are like the very early kind of CPU years in a way. But companies like Intel really pushing this very hard, and it's a great fabric with other companies out there. And I'm trying to understand, where are we commercially? Would that make sense to implement that, in our gear, in our 6G gear, which we'll have by then at the end of this decade?
So how is neuromorphic computing going to roll into 6G?
So it's still a big question mark. So we still don't know. We're still investigating as a community. I'm not saying Ericsson per se, but as a community, we're trying to understand, where will it be? What we are starting to see, 6G will really be about a lot more antenna elements. So we call this UltraMassive MIMO, whatever you want to call it. At the moment, we may have, 64 elements on the roof, and then maybe you have like 6 maybe in the phone. Hey, what if we scale this up to 1,000 antenna elements on the roof? And then suddenly you start thinking, hey, if I have to power all these 1,000 elements and connect all the processing, in addition, my bandwidths are getting wider, more users are coming on, my compute energy, will just go through the roof. And we've done the calculus. It's really crazy. So there's no way we can do that. So we need new ways of dealing with that energy increase. Neuromorphic comes along. It's one of the contenders. So it's not the only one. There's other stuff as well we're looking at. But Neuromorphic essentially gives you the ability to really bring down this energy envelope whilst not jeopardizing the performance on that. So it turns out that Neuromorphic cannot be used for all kind of algorithmic families. So we're trying to understand what can be done, what cannot be done. Should it be in really integral as part of our stack to process data, or should it sit on the side as we like to do it today? This is publicly available, that we just call certain acceleration functions when we need it and then continue with processing. So a lot of question marks, and that makes it so exciting because we need to take very difficult strategic decisions very quickly to make sure we remain competitive towards the end of this decade.
So tell us about quantum computing. I know you're looking at that also.
So quantum at the moment, where are we? The interesting thing about quantum is, nobody believes it would happen. And yet year on year, engineers delivered on the roadmap they had promised before. We have companies like IBM who have been in this for a very long time. You look at their, roadmaps and how they built the number of qubits, over the years. they always deliver on these qubits. So there's no doubt, or somehow the doubt in me has, really diminished down to zero. They will deliver on that roadmap forward. So 26, 27, 28 will be the year where we will have quantum compute fabric, which if we played well will be much more powerful than what we have traditionally, even if we have, very, very big supercomputer centers. And the beauty of processing data in parallel is you can actually solve exponentially difficult problems in an optimum way. So the classic one is the salesman problem, as you decide on what's the optimum way to go for different cities. 24 cities in our traditional compute fabric, no computer in the world can do this, and quantum can do this in a few minutes. Having said that, quantum works really well for quantum problems. Okay, so if you have, for instance, a material science problem, which is a quantum problem, and you have a quantum computer, they can help you to solve that very quickly. If you want to use quantum for digital problems, such as finding the optimum antenna tilt, or doing certain digital tasks, then it's not that optimum, because our current algorithmic frames, like Shor algorithm, etc., they only allow a quadratic increase. So we still need innovation and research on the algorithm side, not only on the fabric. So that's quantum computing. But then we have quantum radios. We do have, quantum networks. We have quantum key distributions, a security element. There's a radio element. There's a networking element. So quantum is just such a fascinating fabric, and it's all evolving. The only downside it has at the moment is it's extremely energy consuming. Okay. Extremely energy consuming. So contrast that with neuromorphic, which consumes almost zero. Quantum is just, you need to cool it, bring it down. So we need a lot of innovation there. And we also need to make sure that if we use a quantum computer, the problem is so hard that we would need like trillions of years to do it on a normal fabric, because then the whole energy story makes sense. It needs to be sustainable.
If you had just a huge amount of funding to look at something that's of personal interest to you, what would it be?
Yeah, I would probably try a little bit what we tried to do in London, push the envelope on both, really. So, try to understand how can we bring the innovative element of technology together with the creative element of the arts, and really get, the both communities start thinking, how can they disrupt their own ecosystems? It's a very general view, but, usually it comes out when you bring them together. And we have new stuff coming out now in technology. And I think this envelope between accelerator fabric like neuromorphic and quantum is one, AI is another, and robotics, we haven't talked about this at all, is yet another, specifically soft robotics. So it's not only about hard robots walking, but actually soft robots, which are quite useful in medicine, many other applications. So that's the technology envelope, and the connectivity connecting it all, 5G, 6G, etc. And then on the artistic side, we have new ways of, procuring the arts, whether you use, let's say, glasses, new ways of stages, haptic equipment, creating immersive experiences, creating emotional bonds, creating a digital aura in arts, which we couldn't do before, right? So before you would go in an exhibition, there's nothing before going to an exhibition, great experience going out of the exhibition, and then you forget about it. So building these digital aura trails, I think, this is where technology can really help. So loads of opportunities there, but really bring arts back into the curricula, bring it back into schools, bring it back into universities, make it an integral part of our educational process. That's really what I'd love to see.
What is a soft robot?
A soft robot is a robot which mimics the way how, let's say, an octopus walks, right? So it's very soft. There's no hard element there, and we love to explore that world because nobody can be very close to a real big robot. So I'm not sure you've ever been close to one. I had one at King's ABB. These are beasts. These are industrial things, and you don't really trust it. If somebody hacks in there or something happens, they just swing and you're just on the way. You're basically toast. But the soft robot can really enable that coexistence, I think, with humans, use it in surgery. So the ability to control soft tissue, like an octopus, I think, or a snake, that's the type of inspirational, kind of biological phenomena we use to design that.
Well, Mischa, everything from octopuses to Apple Vision Pro to neuromorphic computing. Thank you so much for your time today. It's been a fascinating conversation.
My pleasure, Camille. Thank you for having me.
Never miss an episode of InTechnology, by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.